Hey, hello, I'm Maura. I'm with Embrace Tutoring. A little about me. I've spent about 12 years as a STEM teacher in some capacity, teaching uh, at a small private school, tutoring. I even taught physics for 2 semesters at Rutgers University in Newark, New Jersey. Today, we're going to do a quick intro to physics and 1D motion. This is the kind of thing a lot of physics classes, either high school or college, will intro to you in about the first week. What do we mean by 1D motion? In one dimension, so either horizontal or vertical. A lot of physics is not going to be memorization, but solving problems. So the kind of problems you will see are going to be balls being thrown up and down, gravity, you'll see cars moving across flat surfaces. First, a quick definition. We've got distance and displacement. What's the difference? First, well, they both use the same System des Internationale units, meters, but here's the difference. Distance is your total length traveled, while displacement is the distance between, is the length between the starting point and the ending point. In my example, go north 6 meters and south 3 meters. So your distance is your total length traveled. 6 plus 3 is 9. You've physically moved yourself 9 meters. Your displacement is how far from your starting point to your ending point you're ending up. So that's 6 minus 3 meters. For the purpose of physics, we're going to use displacement. If I slip up and say distance, ignore it. It should always be displacement. Some more definitions. We've got speed and velocity. You're familiar with speed from driving a car or being a passenger in a car, 60 miles per hour. Physics instead uses velocity. What's the difference? Well, speed is a scalar. We just want a number and units. Of course, the units for speed and velocity are both distance divided by time. In our American system, we say miles per hour or something, maybe feet per second. But in good old physics, Système International, we're going to go meters per second. So, for example, a fast car may be moving 45 meters per second. That's really fast. That's like almost 2 swimming pools lengths, depending on your swimming pool. So your speed is just 45 meters per second, while the velocity is 45 meters per second in the positive x direction. It's a vector, it's got direction. Okay, now let's put it all together, add some math. Intuitively, let's think about this. Your car travels 30 meters in 5 seconds. What's the velocity? 30 meters divided by 5 seconds. I'm just going to go ahead and use my annotator. Boop. 30 meters divided by 5 seconds is going to be 6 meters per second. So the definition of velocity is going to be the change in your displacement divided by the change in time. Your displacement was 30 meters. Your time was 5 seconds. So you start the motion at 0 meters, 0 seconds. You end the motion at 30 meters and 5 seconds. Now, imagine car A. That's a terrible car. Who cares? Car A and car B finish the same course, while A is doing it in 5, B is doing it in 7. 5 seconds, 7 seconds. By the way, time is not a vector. Time has no direction. Okay, so which car is the faster car? Intuitively, you know it's A, it's doing the job in fewer seconds because velocity is change in x over the change in t. Smaller t is a bigger v. Clear this, moving on. Okay, now let's bring this back to algebra. So I just introduced you to this, which should remind you of Algebra 1's slope. Remember how slope was rise over run, the change in x, or the change in y over the change in x? If you have a bigger y and a smaller x, you have a steeper slope, a bigger slope. Same with velocity. Uh, if you have a bigger displacement, you're going to have a bigger velocity. If you have a smaller time, you're going to have a bigger velocity. That's cool, but why? Well, this represents a constant velocity. See this straight line? It's a constant velocity. You are moving forward, you start at time 0, moving forward, forward, forward. This is, you are moving the same amount of, the same displacement in meters at the same time stamps. Let me see if I can clear that up for you real fast. And clear off my drawings. Okay, you have a car going 1.5 meters per second. Okay, so after 1 second, how far have you gone? 1.5 meters per second times 1 second equals 1.5 meters. Easy, that makes sense. How about 2 seconds? 3 meters, pretty easy. 4 seconds, 1.5 times 4 is going to be 6 seconds. This is a traveling at a constant velocity. Let's go ahead and add some more math to it. So here is the graphical representation of such a thing. So you have time seconds. So this is going to be 1 second. And in 1 second, you travel, sorry, let's see. So this is 0, this is 1, this is 1.5. After 1 second, you go 1.5 meters. After 2 seconds, you find yourself at 3 meters. 3 seconds, going to put you at 4.5 meters, and 4 seconds will put you at 6 meters. You're going to see this a lot, but we're just going to intro the concept, so don't think too much about this yet. We've introduced you to v equals dx over dt. You can move things around in this. You can move things around. By the way, dx dt, when you have something constant, it's going to, d means the change in calculus, it's going to be the instantaneous change, but for our purposes today, we're just going to have it be delta t. So we can rearrange this v equals, delta x over delta t to equal v times delta t equals delta x. Or the x, the total displacement traveled, equals v times the t, the amount of time the traveling takes place. Nice. Cool. Next step, acceleration. Okay, you're familiar with an accelerator. You might think acceleration, speeding up. Okay, also slowing down. Yeah, yes, for the purpose of physics, acceleration will also be slowing down, negative acceleration. Also, just like velocity is a vector, acceleration is a vector. So acceleration is going to be the change in the velocity vector. So let's say, so this is your velocity vector. Let's say your velocity vector is 5 meters per second in the positive x. And then over here, let's say it travels a certain amount. And then over here, it's 10 meters per second in the positive x. So it got faster. It accelerated. Okay, cool, cool. Is that enough to put a numeric value on it? I think I want more information. Let's say that this VO, this V1, let's call this at 0 seconds. Let's say this happens at 2 seconds. So what's our change in time? 2. What's our change in velocity? 10 minus 5 meters per second positive x. 2 over 2 seconds minus 0 seconds equals 5 meters per second divided by 2 seconds. Okay, we're going to say 2.5, and I ran out of space, meters per, the units look messy here, but it's going to be meters per second squared. Or, well, you could say meters per second, but most people say meters per second squared. It's just faster. Clear the drawings and moving on. So, the acceleration definition. So, just like V was the change in displacement over the change in time, A is the change in velocity over the change in time, with units of meters per second squared, or meters per second, but look how sloppy that looks. Let's stick with meters per second squared. Okay, and we'll do another problem. Oh, look, I love zeros and fives. Ha 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 ha. I love zeros, fives, and tens. So we're gonna go, first, let's visualize this. You go from rest to 10 meters per second in 5 seconds. Now try 0 meters per second to 10 meters per second in 2 seconds. Same change in velocity, not speed. Shorter time. Which one has a greater acceleration? The shorter time period. So, and we can, if you want to do the math, we can do the math. The change starts at 10 meters per second minus 0 meters per second. Don't forget your units. At 5 seconds minus 0 seconds. That's going to be 10 divided by 5 is going to be 2 meters per second squared. Or for the second one, A equals, again, 10 meters per second minus 0. We like to look at our change, our final minus our initial. 2 seconds minus 0 seconds. So that's going to be 10 meters per second divided by 2 equals 5 meters per second squared. Hope you can read that. I've been Maura Satirial. If you'd like to work with me, send an email or call Embrace Tutoring. I live in Brooklyn, New York, and I travel. I travel a reasonable distance in the area. Good luck with everything. Hope that was helpful.
Okay, so thanks for watching, and please remember to contact us at info@embracetutoring.com to set up any personalized private tutoring sessions you would like. Stay tuned for future videos, and best of luck with your studies. We definitely encourage you to visit our Instagram as well as TikTok pages if you have any questions along the way. Take care, guys. Best of luck with your studies.